Hello, my name is Daniel Santander. I am a first-year master's student in the Bioresource Engineering department at McGill, working under the supervision of Dr. Lefstrud in the Biomass Production Laboratory. Today I will be presenting on an experiment that is getting underway on the topic of the impact of post-harvest drying and curing procedures on cannabis quality for smokables and extracts. Premium cannabis, cultivated perfectly, can be ruined with poor drying and curing techniques. During this stage of production, terpenoids and cannabinoids are susceptible to degradation due to heat, light, and oxygen. Defining the optimal parameters for drying and curing is paramount for ensuring that phytochemical constituents are preserved throughout the post-harvest processing steps. In this experiment, we first look to broadly compare freeze drying and natural air drying. Freeze drying may be a favorable alternative to conventional drying because its low operating temperature prevents the degradation of cannabinoids and terpenoids. And sublimation of additional moisture is not only faster than evaporation, but also preserves the original structure, shape, and volume of plant material. Following primary drying, we then look to compare the impact of curing methodology on cannabis quality. Curing is an industrial standard in the cannabis industry that involves storing cannabis in a temperature and humidity controlled environment for an extended period of time. The common rationale for curing cannabis is twofold: the stabilization of the cannabis inflorescence at a constant moisture content and water activity, as well as the maturation of the inflorescence for optimal smoking quality. Though curing is an industrial standard, it has very little scientific rationale supporting the procedure. Furthermore, it may not be practical or necessary in the production of extracts or edibles. In order to investigate curing procedures, we will cure cannabis for 3 months at 3 different relative humidities in order to see how cannabis equilibrium moisture content and water activity impact key quality metrics. Additionally, we will cure the cannabis in either hermetically sealed containers or containers that are periodically opened or burped in order to gain insight on how the ambient gas exposure impacts the metabolic degradation of phytochemicals and primary metabolites. With this, our experiment is defined as a three-way factorial design. The treatment factors are drying method at 2 levels, freeze drying and air drying, curing method at 2 levels, burped and non-burped, and relative humidity of curing chamber at 3 levels, 55%, 62%, and 69% relative humidity. During the course of this experiment, we will record equivalent calculated CO2 and volatile organic compound concentrations in the headspace of the curing chamber as a proxy for the respiration and VOC loss. Additionally, temperature and relative humidity will be tracked to ensure fidelity of our curing environment to our set humidity and temperature. In order to record these metrics, we have designed a novel sensor array for logging the environmental data of the curing chamber using an Arduino linked to a separate gas and environmental sensors for each treatment combination. In addition to the environmental data, we will collect cannabis quality data immediately following harvest, after drying, and throughout the course of the 3-month curing period. Of primary interest are terpenoids and cannabinoid content and moisture content at different stages during the curing process. Additionally, color will be analyzed using the CIE lab color space to approximate the human photopic perception of color change during processing. Finally, starch and chlorophyll content will be recorded in order to examine the degradation of primary metabolites during processing. The degradation of chlorophyll and starch is purported to improve smoking quality in tobacco and cannabis products and will be a proxy for smoking quality in our experiment. In conclusion, our experiment looks to define the optimal combination of drying and curing techniques for the processing of cannabis intended for extracts or smokable products. I would like to thank my audience for their time, and the QAQCC and EXCA Incorporated for their support of this experiment, as well as Matt Chartrand and Ithaca Organics for providing photos of dried cannabis. Thank you.